Good morning, Year 10s. Hope you're sitting down, ready to take notes. What we're looking at today is a couple of algebraic methods on using a variety of techniques to solve simultaneous equations. We know a graphical method of drawing them on the graph and finding the intersection, but today we're going to use algebraic methods to find the exact solution. The first one we're looking at is a method called elimination. And elimination is most commonly used when the equation is in general form already, when it's in the form ax plus by equals d. Okay? Now, the logic behind this is that what you do to one side of the equation, you must do to the other. You're used to that, but what you do to one side of the equation doesn't have to look the same as what you do to the other. It has to be the same, but you don't have to make it look the same. One example for this would be if I had x plus 1 equals 4, clearly x is 3, but I could add 1 to this side, and now, because I've added 1 to that side, I must do the same on the other side. But should I feel like it, I could add 6 over 6. Because 6 over 6 really is another way of writing 1. So I've done the same thing to both sides, but it doesn't necessarily look the same. Alright? Now, take this equation down here. This equation reads a plus b equals 12. And that by itself isn't very useful for us, because there are lots and lots and lots of values that a and b could be. They could both be 6, one could be 5, the other could be 7, one could be 4, the other could be 8. There's lots of different outcomes. So, what if I give you that piece of information as well, where a is equal to 7? All right. Now, very clearly you can all see straight away that, oh, b must be 5. Well done, yes, you've got the answer. But if we're going to solve this using the algebraic logic above of what we do to one side, we do to the other, but it doesn't have to look the same, I could write this. A plus b is equal to 12. And then I'm going to take a from this side. So I'm going to use this equation here and take that entire equation away from the first one. On the left-hand side, the equation's an a, so I'm taking the a away. On the right-hand side, but equal to the left, is a 7. So on the left hand, I'm going to take away the a. The right hand, take away the 7. I've done the same thing to both sides. Now, if you do that subtraction, a take a is 0, so we have b on this side, 12 take 7 is 5. What I've done to one side, I've done to the other, it just doesn't look the same. However, it lets us eliminate a variable. Here we've eliminated a. And that's why this is called the elimination method. The aim of the game is to get rid of one of the variables. Here, we'll go through a couple of examples. Please copy them down. And note the working is important. Here, I know it'll feel like there's lots of steps of working, but please do follow them. Alright. First step is, we have two equations. It makes some sense to label them, equation 1 and equation 2. So you can do that using little circles off to the side. Now here, I want to eliminate a variable. And I can see that we have a minus y and a positive y. So if I added the minus y and the positive y together, they would eliminate, because minus y plus y is 0. Alright? So in order to do that, I'm going to take equation 1 and add it to equation 2. And normally you wouldn't include this next step, but I'll show you what's happening here. So equation 1, 2x take y equals 6, and then adding on equation 2. On the left-hand side, I'm going to add 2x plus y. On the right-hand side, I'm going to add the same as 2x plus y, but this time I'm going to call it 7, because I know from the equation above that 2x plus y is 7. So I'm adding this highlighted section to both sides, remembering each one of those highlighted bits is the same. Both sides of the top equation, 2x plus 2x is 4x, minus y plus y is nothing, which is excellent, that was the aim of the game. 6 plus 7 is 13, solve for x. Ooh. X is equal to 13 on 4. Now note, that's not actually the full solution yet. That's just the x answer. We're looking for a point in space where they meet. So what we can do is take that x value and substitute it in to either one of the equations. And remembering from last video, it doesn't matter which equation we choose, because it's the unique solution, the same value for y will pop out. So taking x equals 13 on 4, I can put it into, let's choose the second one because there's no negatives, 2 lots of 13 on 4 plus y is equal to 7. 13 on 2 plus y is equal to 7. Y is equal to 7 take 13 on 2. 13 on 2, remember, is 6.5, so 7 take 6.5. Y is equal to a half. Your solution, therefore, and you must give the point, is 13 on 4, a half. Sorry, my pen's messing around today. Alright, so going through the steps. Look at the equations, work out how you might get rid of a variable or eliminate, add or subtract accordingly, work out to the point. Right. Next one. Here. Equation 1, equation 2, they're the same, but I just said equation 2 and wrote 1, didn't I? Equation 2, if I do 1 minus 2, I'll end up with a y take y, which is good. So then I will have equation 1, which is this, x plus y equals 9, take away 3x plus y equals 12. Now, note I've bracketed the entire equation. That means this negative is applying to everything inside. So really, I could think of that as this. Excuse me. All right. Now, add them together. No, one take the other. X take 2x, x take 3x is negative 2x. Y take y is 0. That was the aim of the game. 9 take 12, negative 3. X was equal to 3 on 2. The negatives go. Not yet the full solution. We need to sub it in. I'm going to sub it into equation 1 because it looks like a simpler equation. 3 on 2 in place of x plus y is equal to 9. Take 3 on 2 from both sides. Y is equal to 9, take 3 on 2. 9 take 1.5. What's that, 7.5? Y equals 7.5. Give your answer as a coordinate point. 3 on 2, 7.5. Alright, 2 more examples, and I apologize because it's a long video. These are, yes, the last 2. Now here, you note, we don't have a pair of variables like before. So always up here we've had singular y's. Positive, negative, we add them together, they disappear. Positive, positive, we take one from the other, they disappear. But that only works if they're of the same magnitude, so the same number of y's. Here, we don't quite have that set up for us. So I'm still going to call them equation 1 and equation 2. And then I'm going to take equation 1 and just multiply both sides of it by 2. Now, we know we can multiply both sides of an equation by 2, so that would mean our new equation 1 is 10x take 2y is equal to 2. All right. And that's what we're going to consider as our equation 1 from now on. Right, so now I have a negative 2y, negative 2y. To eliminate them, I'm not going to add them together because that will make a negative 4y. I'll take them from each other. So now I will do equation 1, take equation 2. Equation 1, take equation 2. I'm looking at 10x, take 3x is 7x. Negative 2y, take negative 2y is 0. Good. Negative 5. Sorry, I've got my equations mixed up. This one is equation 1. Negative 5, negative, I'll get my numbers right one day. 2, take negative 5 is positive 7. Therefore, x is equal to 1. Not yet the full solution. Sub it in. I might put it in equation 1. Actually, it doesn't matter which equation 1 I use. 5 lots of 1 minus y is equal to 1. Minus y is equal to negative 4. Y is equal to 4. Our solution is the point 1, 4. Last one. Here, it's trickier again. Because here, I could just take the negative y and multiply that entire equation by 2, and it would line up with another variable, line up with the other pair of y's. Here, there's no similar course of action we can take. We can't take 3x and multiply it up by something to get 4x, not if we want to use whole numbers. So instead, what we do is look for the lowest common multiple between a pair. And it doesn't matter here if you eliminated x or eliminated y. For some reason, people tend to pick on y. So I'm going to try and eliminate y first. If I have a 2y and a negative 3y, I want to make them both 6y's. That way they're of the same magnitude and I can eliminate them. So I'm going to take equation 1 and multiply it by 3. And that will give me 9x plus 6y is equal to negative 15. I'm going to take equation 2 and multiply it by 2. And that's equal to 8x minus 6y is equal to negative 2. I'm then going to add equation 1, our new equation 1, and our new equation 2 together. If I add them together, we have 9x plus 8x is 17x. 6y plus minus 6y is 0. Negative 15 plus negative 2 is negative 17. Oh, isn't that nice of them? X is negative 1. Sub it into one of the equations, doesn't matter which one. 3 lots of neg 1 plus 2y equals neg 5. Neg 3 plus 2y equals neg 5. 2y is equal to neg 2. Y is equal to neg 1. Answer as a point, neg 1, neg 1. And of course, if you wanted to check, you could plug it into your CAS and watch where those lines intersect. In OneNote, using the method of elimination, please find where those two equations meet. Sorry, it was a long one. Thank you very much.